Okay, let's try this. Hello, Bo. Great to have you here. I just realized that you haven't heard anything I said before. And it's not the audio that was low, it was just off. And that's one of the perks of using REAPER for streaming. Like I am using this REAPER instance for streaming and my audio is coming from here. But I have another REAPER instance for developing and the two got mixed up and you couldn't hear me. But now you can. So hello, let's write some code together, shall we? The joys of streaming. So what we are working on is this library that has a design system and some data structures and other things that will help you develop better looking and easier to develop JSFX. We are working on data structures. Right now, we are done with... So we have some data structures that are just for undefined variables and errors, which is useful because we have no notion of undefined variables and we have no notion of error handling in JSFX. And I'm trying to keep this as much as possible in the JSFX language so you don't have to learn extra constructs from other languages. So in JSFX, the only kind of value is a number. So I'm using these weird numbers. Hopefully they are not too useful outside the context of the library. So I picked them to define what is an error and what is undefined. And this is like variables that I have not used yet. Like this one. I have defined it, but you need to call this function before you can use the variable. Then I have this MemoryIndex situation, which is for initializing memory. So in JSFX, there is only this big chunk of memory and you have to organize it yourself. And my library is going to help you do that. Help you assign some structure to the memory that you have. And now I just realized that I think that these variables should be private to my library. And they need to be global because there is no other way of hiding the variable. So the variable needs to be global. And therefore, it will be visible from the users of the library from the outside. I'm not sure if there is a way for me to make this private in any way in JSFX. I don't think there is. So I'm going to use a naming convention instead. 2 underscores means this is a private thing. You should not be using that. And I think that we already established this naming convention here. So that's good. Next, we have this memory manager situation works in 3 parts. We have a memory begin, a memory allocate, and a memory end. So this is something that you must call to initialize the memory management situation. And it is an optional variable. It's going to start at 0. And I suppose that you are always required to call this function, so I better say that this memory index is undefined to begin with. And I think that this will work out fine, because if you forget to call memory begin, then this will be a very large negative number, which I don't think is a valid index into the big chunk of memory. So I think that that will work out. I don't think that's a valid base address into the memory. And Bo says, updated the RMS code as per your suggestions. Definitely sounds better. Awesome. So what Bo is talking about here is some private communication. He's working on a couple effects, one of which is a compressor and the other is a leveler, which is kind of compression as well, but it works different. And I suggested some things that I think could be improved, and it seems like they improved things, which is great. So let's see. I'm trying to think if there's anything else that we want to change about this, but I think that this is all right. Yeah, this is incrementing the memory location by this size and returning that memory location. Then to end, we just signal to Reaper that everything from that point on is available, and we return that address in case you need it for some other library that you're using or some other memory management that you want to do by hand. So I return that index to you. And I have this fix me here, so we might as well just address this, which is how do we initialize the memory to zeros? Initially, the memory is set to all zeros, I think. I think that Reaper guarantees that. But we could set it to zeros ourselves. And let's think about the trade-offs of doing so. First of all, is it easy to do? The answer is yes, absolutely. It's super easy to set the memory to all zeros. Why would you want to do that? Well, if you are allocating memory in the slider block, for instance, then I don't think there is a guarantee that the memory will be zeroed out. And I don't think you should be doing that. I think that you should be initializing the memory in the init block, and you should allocate as much memory as you think you will need in the worst case scenario if your sliders are cranked up in the specific directions that need more memory. So if I do it like this and I don't zero out the memory for you, then if you try to allocate memory in the slider block, you will end up in trouble because the memory will not be zeroed out to begin with. So there is an argument for zeroing out the memory. Now there's an argument to not doing that, which is maybe you want to keep the previous values, but they may be in different places. So yeah, I think that's a definitely win. We need to zero out the memory. So let's do that. I am going to look up the documentation for this because I don't remember exactly the arguments that I need to pass to this. And I think it's called like memset. Yes. So when you're ending, I'm going to set the memory to a certain value, which will be the number 0. And the destination is the base address. So I need to remember how it all began. And that's what I'm going to do now. I'm going to have an MemoryIndex start, which will be undefined to begin with, but I will remember that address and I will never touch it. And then at the end, I'm going to use that as the base address. And for the length, I'm just going to subtract where you ended up from where you started. And I believe that this is correct. Yeah, everything about this seems correct. The only issue may be I'm doing free mbuff, which is just a suggestion to Reaper that this is available memory, but then I'm returning this index to you and you may allocate more memory yourself. So this free mbuff may be lying to you. And that's something that I probably want to document, but I think that this is a good thing to have. If you're only using my library, it will do the right thing. If you're using other libraries before you use mine, you can pass the memory index here and it will do the right thing. So this is really an edge case, and I think it pays off to have it like this. And maybe you can even allocate more memory and call free mbuff again to up this number. So I don't know how Reaper would react to this function being called twice, but I think it's fine. Now I really don't like this lMemoryIndex variable name, so I'm going to rename it to lMemory next available address. That's what this is, right? I'm doing this in terms of addresses. But then this variable doesn't really make sense, so I'll call this the address start. And I will reorder so that the address starts is first. So when you are doing the memory begin situation, you're not giving me the memory index, you're giving me the memory. You're just giving me an address. And now let's see how this reads. Just renaming variables, but it's important because it's telling a story. So memory address start and next available address. To begin, you give me an address, and that will be the address start and the next available address. Then when you allocate, you give me a size, and I have this local variable called address. The address is the next available address plus equals size, and then return the address. And when I end the memory allocation, I set from the address start all values being 0 up to the next available address minus where the address started, the addressing started. And I say that this is where the memory starts being free. And then that's what I return as well. Okay, so I think that this makes a lot of sense. Now let's look at enumerations. It starts undefined, and then when you define an enumeration, I zero that value. I start that value. And I think that I'm going to rename this as well. What this is the next available index. Well, it's not really an index. It's not indexing into anything. So this is the next unique value, because enumerations are just unique values. Not unique, because they are not unique throughout different enumerations, but the next distinguishable. Next, what do I want to call this? I am curious about something. Oh, okay. My gate is set such that you cannot hear the music in my living room. I was wondering, can you hear like the baby music running in the living room? You probably cannot, which is good. Or maybe you can just when I'm speaking, because it opens the gate. Whatever. L enumeration next. Distinct value. I think I'm going to call it unique for now. And this actually brings the question, do we want all enumerations to share one namespace? That may be actually a good thing, actually, if we think about it. Because you may have multiple enumerations. Things like filter types and compressor detector input types. And then these two actually end up being the same value. And if you, for whatever reason, make a mistake and you use this variable in a context that this variable should be, then it will be a problem, right? Because it will match, and it shouldn't. It should be an error. It should be. So maybe all enumerations should share the same namespace, the same set of values. And then enumerations are distinct throughout the program. Even different enumerations don't share the same values, and they become really unique. So I guess that's what I'm going to do. And then I don't even need this enumeration define situation. And I know that I'm using it here, so I will have to revisit that. But yeah, I think that this is advantageous. I will have one notion of enumerations that will be for all enumerations in the program. So I have to revisit all these as well. Let's look at what they are doing. Well, first of all, I only have 3 of them, but these 2 are easy to fix. I just don't need them. This one is not as easy because it's using enumerations for these pages, and I was already on the fence about doing this. I think it may be better for me to be explicit about this. And I think that's what I'm going to do. Because these values may change order or whatever may happen, I think it's better for me to be explicit about this enumeration. So here we are. And then the same over here, all these definitions don't need to occur. Yeah, I think I like this change. Then let's see. Then we start the struct stuff. Let me think about this for a moment. I'm calling this like the next available address, and that makes sense. But I'm calling this the next unique value. But that value has already been used at this point, because that's what I return. In here, I am incrementing and then I'm returning the old value. So it means that this really is the next available address, but this is not the next unique value. It is the value that has already been used. So I think I'm just gonna call this like the index. Right? I think that reveals the intention a little better. Now let's talk about structs. They are the hard issue that we tackled last time on Tuesday. And we'll revisit now this implementation before we can do arrays and circular buffers, which we will do today. That's a promise. Let's go to structs. So this is the definition that I'm currently working on. And it starts undefined. So maybe I will rename this variable as well, trying to reveal the intention a little better. Yes, those are all the locations where this is happening, and this is a private variable, so I'm going to put 2 underscores, and I'll call this the current definition. That's the definition that we're currently working on, and it has to be a global variable because these functions need to collaborate with the same global variable. And Lantertronics, Aaron is here. Hey, great to have you. Thank you so much for this series. There is lots of tutorials on YouTube on scripting Reaper in general, but almost none on writing JSFX at any level of depth like you are doing. Thanks. Yeah, right now it's still very high level, I would say. It's very beginner stuff. It's just like functions and variables and very basic operations like adding stuff. But this is like a stepping stone. And really my ambition is to work on deeper, more interesting problems. For instance, I want to develop a compressor, and I want to develop all sorts of fun filters like Windows Sync and Chebyshev, is that how you pronounce that? And Butterworth. I want to define all those kinds of filters, and I want to work on things like autocorrelation for doing a tuner, a chromatic tuner. So yeah, expect a lot more of the deep, low-level mathematics and yeah, all sorts of fun stuff that we all know and love. So yeah, and of course we need these basic things like data structures to work with, because if you're just working with memory directly, there is a high chance that you will mess things up, and this library is giving you some sort of memory safety, and it's just more cumbersome to use if you just use memory directly. So now I'm building the foundational steps to be able to build more interesting things. Yeah, Bo agrees. He thinks that we should make more advanced filters. Yes, I'm interested in developing I'm probably going to put in this library the basic filters. Like maybe I already take note of this because I don't think it's here anywhere. So let's talk about filters that I want to have in the library. I want the basic Robert Wilson Johnson filters. Those are the ones that we used in the streams before. So that's easy. I also want the SVF filters that ND Simper developed for EQH on Ableton, and that is also used in ReEQ by Justin. And the difference between the two is that this guy is better at automation. If you're changing the filter parameters, it is going to react better. It's more stable numerically. So if you want to have like a synthesizer and you want to have some sort of filter LFO on the synthesizer, then using SVF is better than RBJ's parameters. But also things like Windled, Sync, and Butterworth. Is that how you pronounce this? Is that how you spell this name? Is that the right name? It is. And yeah, there are others. I want to do many of them. Mainly because I'm interested in learning them. But they are useful for different things. Like this is useful if you want to filter an audio signal and you are interested in the response in the frequency domain. And there are other kinds of filters that are better for the time domain that don't ripple as much. And that's important if you want to like do a low pass filter on the signal of the gain reduction on a compressor. Yeah, we'll get there. It's a full story. All right, let's get back to so Bo is asking, have you cracked how the RBJ filters work? Can you implement different smoothing formulas in them? I think I understand a little better than I did when we started implementing the RBJ filters on Aria's stream. But I cannot claim to be able to reproduce all these steps because I don't know how to carry out all the mathematics. But I know where it comes from. It's like you look at an analog filter and what an idealized and perfect analog filter would do. And then you do this thing called a bilinear transform, which is like a mathematical operation on the mathematical description of this circuit. And then you simplify a bunch of trigonometric, identities. And then you also take into account things like pre-warping of the filter. It gets complicated, but I think I understand a little better now, and we can talk about it later. But can I implement different smoothing formulas? Maybe. We'll talk about this, but not right now. It's a different headspace. It gets complicated, and I don't fully understand everything about it. Right, so we have this definition size, which is this field in the struct. And I think that at this point, maybe I'm going to save this and commit this because everything in here I like, but I'm going to pause and I'm going to create a data structure that I have not really described here, but I think it may be an important one. So let's talk about this, which is this notion of just an address. Because right now I have this current definition, which is just an address. It's just a box that I can pass around. And maybe I will have this, I will reify, as people would say. I will make this explicit. I will create this notion of a box. So I'll call this the box. And what this is, well, it's first it's a function. And this is just a box. So what this is I have to allocate some memory for you. And I have to allocate just one slot. And I return that slot to you, because remember that allocation will return the address, and I'm just going to return that address for you. Now you may be thinking, well, this is silly. You're just returning a box to me. You're just returning an address. Why couldn't I just do this? And you could, But I think it's nice to have this as a proper name. And I'm not sure that I like this name. Some people may prefer different names. But the thing here is, let's write a test for this. And I will show you why I think this may be a good thing. This test is going to go right after the tests for enumerations, but before structs, because I think that structs will use this. So I will... first I'll save this, because I think that maybe these tests for enumeration are going to fail. Where do I have tests for enumerations? I have tests here for memory. And then I have this silly test for enumerations. That's going to pass. Then I have a bunch of tests for structs. And I have some tests for arrays that I started writing but have not fully implemented, so they're commented out. But right after the tests for enumerations, I am going to create a test for the box. Oh, but before I need to initialize the box, right? So let's go to where I am using enumerations and before structs, so right here, and I'll have a box. What am I going to have on this box? A box is really just one address that I can pass around, and this is used for things like passing by reference, which is something that you can do in C and C++, and I think you will need to do that in JSFX, but there is no notion of passing an address in JSFX, so that's why you need the box. But what could go in a box? I guess I would just call this like a counter, which is like a silly thing, but it will be a box. Oh, and I think I also need box set and get. Yeah, so this will be a whole thing. Let's do it. I'll have a box new set, and here I'll need the box, and I will need the value. And I will just do box at 0 equals value, which will return the value as well, which is beneficial because a setter should return the value, I think. And then a getter will be super silly. It's just this. Now, this implementation is so silly, but I think it puts a name on something that is super useful. Now let's go to the demonstration. So this is me creating a box. And then go down to the test and let's have counter. Well, maybe we'll say assert that when I use a box set on this counter and I set it to, maybe we can say that this is going to be 0. Oh, not really necessary. I don't need to initialize that because I initialize everything here. So I don't need to worry about that. So maybe I will set to the value of box get counter plus 1. And maybe even this notion of a counter may be something that we want to have. So I'll take note here. Maybe for the circular buffer, we will need a circular counter. Maybe we'll want to have that as a data structure that you can use as well. Let's see. If you do a set of get counter plus 1, I expect that to be the number 1. And this is in fact already testing the getter as well as the setter, so I think that this is a good enough test for everything. Now let's see if this test is passing. To do that, I need to do a full compile reset, and no, there is a problem. I am using enumeration define somewhere. Not here. But there. Okay, so I did a full compile reset. Oh no, I think I pressed the wrong button. Let me see. Okay, everything is still alright on the stream. Let me catch up with chat and then we'll see the tests. O says, yes, as I understand, analog filters are like IIR filters. Interesting. But I don't think that's the case. I think that you can have analog filters that are finite impulse responses as well. I am not sure. Analog for filter. Yeah, it seems like it exists. Is there any analog equivalent of finite impulse response filters? I agree to cookies. This is junk, isn't it? Yeah, this is mostly junk. For analog low pass filter. Yeah, I think that it should be possible. Because IIR, or infinite impulse response, versus finite impulse response, FIR, has to do with the operation of the filter. If you have some sort of feedback when the output of the filter is feeding back into the inputs of the filter, that's IIR. And I believe that most analog filters work like that, but in theory they could work with finite impulse responses as well. By convolution, for instance, you can do filter by convolution. You convolute the filter kernel with the input signal. So you could do that with analog circuitry, I think. Sure, go ahead with the library. Okay, both IIR filters in DSP and analog filters are built with resistors and capacitors and inductors and op amps and are quite analogous. To get FIR filters in analog, you need to use a bucket by... Okay, those are things that I don't know about. Which then is a discrete time filter. Convolution is a theoretical operation. Convolution is a theoretical operation? Well, why do you say that it's a theoretical operation? I don't fully understand that. And I don't know what a bucket by grade device even is. If you're building a filter with op amps and resistors and capacitors and inductors, you can't build an FIR filter. They will have to be IIR. So convolution is a theoretical operation. I don't fully understand that. As far as I understand, convolution is just multiplying and adding things together, which is, I guess it's theoretical if you want to write down the formulas for things, but it's very much a practical thing that you can do even in analog circuitry. You can multiply values and you can add values together. You can write this formula, which is the formula for convolution, where the impulse response is finite, but that doesn't mean you can actually implement it with a particular technology. If you're doing DSP, if you're in the digital signal processing domain, not in analog, you can convolve with whatever impulse response you want. Yeah, but even in electronics, you can have circuitries that are like integrators that will add up all the things, and you have things that can multiply. So you could have like an oscillator that is just outputting the frequency, the impulse response, and then you could add it, multiply it. I don't know. I can think of another way to make a time domain FIR filter that doesn't discretize the signal in time. I don't know. People on Stack Overflow seem to discuss this idea, so there may be something to that. But I'm going to continue with what I'm doing and check back in a moment. So I was talking about boxes, and I wrote a test for boxes. So now let's see if that test is passing by doing another full compile reset. And oh no, I think I pressed the same wrong button again, but I'm still fine on the stream. Let's go to the data structures, and there are some failing tests. So let's address them. So the third test is failing. Let's go to a search and go to the third test, which is this. So this is failing already. Why is it failing? Let's see what box, or not box, but counter. This is the address of counter. So before we use the counter, let's create a debug variable that is equal to, or maybe let's commit what we have before we start this investigation, right? That's a smart move, I think. Yeah, writing tests now. So I'll have a debug variable that is equal to counter at 0. And that we expect to be 0. But it's not. Oh, that's because this is running in a loop and the counter is never reset. So instead of doing it like this, I think that we need to set the counter to a particular number, like this number. And then we need to write another test for the getter. And then I do a full compile reset and I go back to this, and then the third test is passing. Great, we fixed one. Let me commit this fix. So the fix was actually in the tests. The tests were wrong. Now let's address the other ones, but I think that they all have to do with structs, which I have broken anyway. So let's reload this and see if there are still some failing tests. Okay, everything is passing, so the problem is now structs, but I know I broke structs. Because I changed the way that enumerations work. So let's go over structs, and then I will go back to the chat and follow up with everything that I don't know about analog filters and FIR filters. I'm still learning. That's entirely the point of doing this. I want to learn these things. So this is the current definition of a struct that I'm working on, and I think that instead of doing allocate of 1, I can use a box. And then, so I create a box, and then I am going to do something in, what is this? What is this variable? I think it's just a variable that I forgot to rename. Isn't that the case? Oh, so this is actually a good opportunity for me to show something cool. This variable I forgot to rename. I think it should be called current definition. I think that should be like this. So I can show you something cool in terms of debugging JSFX. So it goes like this. If this variable is not defined anywhere, it's a global variable. I did not say that it's local to this function. I could have said that this variable was local to this function, but it's not. So it's a global variable. And there is only one reference to this variable in the program. That usually indicates a mistake, because if you have only one reference to a variable, you are setting but never reading that variable. It's a warning sign, at the very least. And over here in the inspector, or this pane, there is a very cool thing, the references. And if there is a variable that has only one reference to it, it's probably a mistake. And you can see that there are several of these, but let's focus on the one that we care about. So if I'm suspicious about this L struct definition, let's go to L struct definition, and you can see that there is only one reference to that. So it's confirming that probably, yes, this is a mistake. It should be current definition. But we now have a box, so we don't have to do it like this. We can say L box set the number 0. And then I can remove this line. And then I can return the box itself. Then, I guess that in many cases when I create a box, I will want to set the initial value. No, not quite. I think that in many cases I want to create a box in the init block, but it may not have an initial value for that, and the default value can be 0, so I can just trust on that being 0. So maybe I don't even need this line. And in that case, I don't even need that line. I can just do it like this, which is cool. I can just rely on the fact that the box will start as 0. Then, when I want to create a new field in the struct, what I do is I go to the definition and I add 1. Now I need to rewrite this line so that it is lbox set. What is my box? The current definition. And what is the new value? It is lbox get of that plus 1. So that's equivalent to this line. And then I also need to create, I need to return a unique number that is the index into that struct, the position in the struct where we will find this field. And here I was using enumerations, but I'm not going to use enumerations anymore for this. So instead, I have to use this address itself. Now let's think. This is going to start as 0, and that's the one that I want to return first. So I think I will need to do a similar trick to what I did above, where I have a local variable. And I'll call this the field index. And that's going to be the current value of the L struct current definition. And then that's what I return. So these 3 lines look similar to these 3 lines. Similar spirit. And by the way, the 3 lines that I was referring to. Oh, Sibo, I was reading your stuff. That was me reopening the previously closed tab. So yeah, these 3 lines in memory allocation look a lot like this line, which is effectively allocating a field in the struct. So it's no coincidence that they look alike. Then to create a new, so let's think about this. This definition size stuff is going to go away. And I guess even the size and the fields are going to go away because I'm not going to use enumeration for that anymore. So the only global variable now is the L struct current definition, which starts undefined. It's a box when you start creating a struct, and when you add new fields, you use this counter itself as the field index. And then when you're creating a new struct, so this is the definition of the struct, and this is you instantiating the struct. So you receive the struct definition, which is the result of calling this. And you have these 2 local variables here. We'll see how they are being used. So let's see. The struct definition size is just getting the value of the box. Because a struct definition, remember, is a box. So I can use lbox get of the struct definition to get its size. Then the struct itself, I am going to allocate memory. So I'm going to allocate 1, which is the size, plus whatever the size is. And that is so that I can store the struct size on the struct itself, which will be necessary when I am doing getting and setting on the struct, because I want to do bounds checking, the whole memory safety story. So I'm going to allocate 1 field for the position, and then however many fields I need. And then at position 0 of the struct, I'm going to store its size, and then I return the struct. And I think that all of this makes sense. Yeah, I'm wondering if I should have a name for this magic number. but I think I will not. Do I have a precedent for this? No. So I think I will not have a name for this. Then we'll have two private functions to check if this is a valid field. And given the struct and the field, I will check this, and I have to rename this to be lbox get of the struct. And then I just check if the field is less than... Oh, no. This is incorrect, actually, because this is an instance of the struct, not a struct definition. So this is not a box, though it would happen to work because I'm looking at position 0. But I think it reads better if I do it like this. And what was it before? Yeah, it was using a name for that. But I'm taking back the name. Then to check if... To get me a field index, I just have to add 1 to the field. Because this 1 position is where I'm storing the size. Then to set, I get a struct, a field, and a value, and I check if it's not valid using this auxiliary function. Then I throw an error. I don't throw an error. I return a stupid dummy value. And then otherwise, I go to the struct at this position, and I set the value. And to get the value, I do something very similar in terms of error checking. I just get that value. So I think that everything in here stands. Now let's go to the tests, and I will work on the tests, make the tests pass, and then I go back to the chat. So in terms of using structs, I define, and then I have some fields. And you know what? I think I'm going to rename these variables to be like this. And I played a trick that you did not see, but I selected the variable name and I hit Command-Shift-L, which selects this variable name everywhere in the program. So you can see that further below, the names have been changed as well. So I think I'm going to establish this naming convention for structs. And maybe I will even do it the other way around. Yeah, I'll have a struct coordinate x, struct coordinate y. Yeah, that's going to be my naming convention for now. And then a label position is a struct that instantiate. Then let's go to the tests where we are using the label position, and I don't think I changed the API. It's still set and get. So if I renamed all the variables correctly, I think that this is just going to pass. Okay, it's not passing. Let's commit what we have. Read the chat. And then get back and fix whatever is wrong. And I promise in the next 40 minutes, I will implement at least arrays. If not circular buffers, at least arrays will go out. GSPT4760. Hello. Bucket brigating. It's a brigade. Bucket brigating is saving values in a delay line, right? Well, a delay line is very apropos because I am promising that I'm going to implement a circular buffer, and that's what a delay line is, or you can use a circular buffer for a delay line. Bucket brigade devices discretize in time even if they don't in amplitude. Oh, that's interesting. Usually you either have continuous signals in the time and amplitude domains, or you have, they are either continuous or discrete in both axes at the same time. But you can, why not, have something that is discrete in one axis and not the other. discrete time continuous value. Interesting. When people do DSP on the computer, your discrete time discrete value. Yeah, as I was saying, usually it's continuous in both axes or discrete in both axes, but not a mix. But you can mix the two. Okay, Aaron has written nothing fancier than MATLAB or SuperCollider. In the former case, it's not real time. In the later case, the SuperCollider library does most of the work for you. Yeah, I guess what I'm creating is some of the primitives you would find in SuperCollider, but I'm creating them in JSFX because not only I explained already why I want to do this library, but I will briefly explain again. I absolutely love the iterative development cycle of JSFX where you can save and the effect just starts running on audio. And this pane is so useful. And they are so easy to distribute, and they compile natively to, I think they compile natively to all platforms. It's just amazing. I really like JSFX. I just don't like what it's missing. I think it's too low level. Also, I want to learn this stuff. So, mostly a theoretician. Oh, what kind of theory do you work on? Do you work in analog filters or something like that? Oh, okay, so Aaron is no longer here. Anyway, thanks for having you while you were here. So let's see what tests are not passing. We have, from the 6 final tests, we have fail, fail, pass, fail, fail, pass. Let's go to the source code. And from the last 6, we have fail, fail, pass, fail, fail, pass. So when I am setting to something that is out of bounds, then this is passing. So the bounds checking is correct. Or at least, if the bounds checking should fail, it is failing. But if the bounds check should succeed, they may not be succeeding. Even if they are succeeding, there's something weird going on in both the setter as well as in the getter. What could be going wrong? Let's see if we can just nail just by looking. I don't think I can. So I'm going to start by inspecting what I expect this struct to be. So I expect a struct to be a weird number, which is like the address to the box. So struct coordinate, I expect to be something crazy, and I don't care about it. Yes, it is something crazy, I don't care about it. Now x and y, I expect to be 0 and 1, and they are. So at least that much is correct. Then, did I commit everything? Yes, so I can start writing some debug code here. Now, what do I get when I do this set? I was supposed to get the number 10, but what do I get? I get error. So probably the bounds checking is not working. Right, let's check. Yeah, I only get an error if the bounds checking is not working. So let's see, I use the field, a struct and field, and I check position 0 of the struct, which is the size. So let's check what we have at label position at 0. I expect to see the number 2, but I see 0. So something is wrong when defining new fields. I trust the boxes. So I don't think that the box is to blame. Another thing is, I only defined one data structure, so my struct coordinate is the place in memory where I have this structure. It's position 21 in memory. I expect the Shadeless. Did we define shadeless? Oh, yes, we did. Okay. So I expect I expect two things to be equal. One is struct coordinate, that is our definition, the place in memory where we store this size. And I expect that to be the same as something else, but I forget what. Oh, I expect that to be the same as L struct current definition. That is the same. And then, what do I get if I index into this? I suppose it will be the same number 0. But let's save and do a full compile reset. Then debug is 0. So it's not incrementing. It's not doing this. The crazy thing is that the struct field will return values, and that's what I'm using here. And struct coordinate x and y are correct. So that is absolutely crazy, isn't it? This doesn't make any sense. Is there a way to use JSFX outside of REAPER? I think there is a Docker behind the thing, Windows only, and there a Docker kind of thing, Windows only, and haven't been updated since 2016. Yeah, that is correct. As far as I can tell, if you want to use JSFX outside REAPER, you have two options. The first is something called replugs. They are the stock REAPER plugins for Windows only, updated last time in 2016, but they support JSFX. But of course, not the latest JSFX, not the kind of JSFX that we are writing. We are going to use features that have been released since 2016. So that's option number 1. It's not great. Option number 2 is not great either, but it's something you can do. You can route audio from another DAW into REAPER, use an effects chain to process using JSFX, and then route the audio out of REAPER into another DAW. Effectively something like what you would do to a piece of hardware. If you have like a hardware synthesizer, you can run audio through that. Not ideal, but that's what you can do. Okay, so what the hell? We are in a situation that is super weird. Let's check our assumptions again. So we have here the definition of the struct. And can you hear that when I'm silent? Oh, my gate is so good. There is loud music in the other room, and you cannot hear it when I'm quiet. You may hear it when I'm speaking. YouTube, please don't copyright claim this video. Be nice to me. Okay, so struct coordinate, field define, struct define, and all of this seems so nice. Let's have some debug variables here in the middle. I will have debug 1 to check this, and I expect, I'll even say debug 0 because I expect it to be 0. Then when I define this, I expect that to be 1 and then 2. And it is correct, so this much is working. And then I define a new struct like this. So I expect debug, I don't know, again, 0. Oh, I don't expect that to be 0. I expect that to be 2. So again, 2. And it is 2. So all of this is making sense. But then, when I look at exactly the same thing over here, the debug variable is 0. See, isn't that crazy? I'm checking exactly the same expression, just in different contexts. Debug is 0 and debug again 2 is 2, and they're checking exactly the same variable. I'm going to remove the noise to make this stand out. This is absolutely crazy. No reason for this to behave like this. No reason whatsoever. It makes absolutely no sense. I'm baffled. I'll have a debug1 variable, which is label position at 0. And I'll have a debug2 variable, which is also label position at 0. They're not the same value. What could be happening to the memory in between these things? Oh, I know exactly what's happening in memory. Memory end is resetting everything. That's what it's about. Well, memory end is resetting everything to 0. But we have used memory already. When defining stuff, we used memory. That cannot be erased. That's the issue. Okay, order has been restored. Now we only have to think about what we want to do to fix this. Simple. Well, we can just don't zero out the memory. Yeah, we can just not zero out the memory, right? Let's prove that this is the issue. If I remove that line and do a full compile reset, then all the tests will pass. So that is the issue. Now, we just made the argument that we want to zero out the memory just to be sure that everything is zeroed out in the beginning. We even used this assumption when writing the rest of the code. So maybe I should not make this assumption. Yeah, right. There is no way for me to define struct new because it's going to allocate memory. So it needs to happen before LMemoryEnd. And it needs to store a value in there. It needs to store the size of the thing for me to do bounds checking. So I cannot set the memory to zeros. Yeah, I will not set the memory to zeros. There is no way for me to do that. But then I need to rethink everywhere where I'm using memory. It may not be zero, so I need to be smart about it. So let's see all the places where I'm allocating stuff. Okay, in this case, I'm only allocating the memory chunk, and I think I am not I'm not relying on the memory chunk being any particular value. Right. Then over here, I'm allocating in 2 places. In the box, and I can just say that you can give me an initial value for the box, or you just have to set. Yeah, I think you can give me an initial value. I can just give me a value, and that will be fine. So I'm going to allocate some memory. I'm going to create a local variable for a box that I'm going to return in the end, and box at 0, or maybe even just L box set of the box and the value. Okay, let's find all the places where I'm starting a box. And I think we are good box-wise. Let's go here and check all the places where we have boxes. And let's initialize this as well. Maybe to a crazy number, why not? Let's initialize this to a crazy number. I'll initialize this to this number. And then my counter, I expect to get the crazy number, and then to set and get, and yeah, all of that seems good. And you know what? I think I'm going to make this memory begin explicit. And this way, I don't think we have any optional variables, any option arguments in the library, which may be good, maybe a good thing. Okay, so we looked at all the places where counter was used, and then we need to continue looking, and all of that makes sense. And then here I am getting stuff from the box, setting stuff to the box. Here I'm allocating memory. Here I'm going to allocate memory. So maybe I should zero out things in the struct. No, I'll just say that this is undefined. Yeah, you should set before you get anything out of the struct, or you may get junk. You know what? It is so easy for me to do that. I will do it. In terms of mem set, I will set this to undefined. So what do I want to do? I want to get to struct plus 1, because this is the 0th position, so the struct plus 1. And I want to set L undefined, and I want I can do this here as well, right? When I'm allocating memory, I could allocate to a set undefined there. I think I'm going to do that. So at least I have a specific value for undefined. I think that's advantageous. So let's see. When I'm allocating memory, I allocate this much, and then I mem set at position address for, I'm going to set L undefined for size. And then because I did that, I don't need to do it here, right? Because I am going to allocate some memory that will be undefined, and then I set the first position and the rest will be undefined, and I return the struct. This remains the same, that remains the same. All of this remains the same. So now the test should still be passing. Okay, they're not. I cannot use lbox set. Okay, now the issue is that this function is being used on new, so I need to probably do it like this. There we go. And now let's see if the tests are still passing. No, they're not. The third test is failing. And this is the third test. My counter is not being initialized the way it should. Oh, right, because I need to... Oh no, I'm getting the value from there, and yeah, it's just not initializing correctly. Well, I'm going to commit what I have, and then we'll try to fix this issue. Okay, so what changed? Let's see what's up with chat. Thanks, Landro and Bo. Sure, no problem. And I know that this emoji is supposed to be like this, but it looks like you are like giving money to someone. I don't know, this emoji is so weird. Okay, we did a bunch of things. We are saying that when we are allocating memory, I am setting that memory to be undefined, explicitly. I'm not sure that this line is correct though, so let's go to the JSFX documentation again. Yeah, destination, that's the base address. And that's the one that I'm using here. Okay, value, undefined, and size, length. I suppose that this is going to be the same as this. So I think that this is correct, but I could write a test for this. First, I'm going to commit. Let's continue this diff. Then I reordered this because I am receiving an initial value. So I'm allocating, setting that initial value, and then returning the box. Over here, I am initializing this box to be 0, being explicit about memory initialization. That all looks good. Then let's see what we changed over here. We are making the memory begin explicit, and we are making use of the initial value and adding a test for that. The test is failing. Let's write some tests for the memory initialization stuff. So maybe before I do this sets to memory, I will assert stuff about memory. In particular, I can assert that this is equal to L undefined. Let's see if this test is passing. Fail, pass, pass. Okay, so the first test is already failing. So the mem set is not occurring. Yeah, I think this will be a wild ride. Let's see. I committed because I want to start writing some debug statements here. So the first thing is already not passing. What do I have there? $1,000. Oh, do I need to do a full compile reset? Now it's 0. 0 is also not the correct answer. I mean, the test is going to fail, right? Yeah. But I think I understand two issues here. First is that this is not going to fly because this is running in a loop. So when I try to assert, the next time I go around, the memory chunk will be 1,000. So this test is nonsensical. But even the first time I go around, this debug variable should be updating. It's not. When does it turn to when I go to data structures, then it runs, and then it's undefined for a brief moment, and then it turns into 1,000. Okay, so the test is the test doesn't make sense because this is running in a loop, so the memory chunk will be set the next time we go around. Okay, so that is part 1 of the mystery solved. This is not a good test. I cannot write this test. Not right here anyway, because I'm running this in the JSFX block. So that's why the test cannot be written. But I have other failing tests. So it's pass, pass, fail. Let's see. Pass, pass, fail. Oh, again, I am testing the value initialization, but this is in a loop. So this is also a nonsensical test for me to write. Now everything is passing. I'll just have to trust that the initialization stuff is initializing stuff. And we even saw it for a brief second over here, so we can trust that part. Okay, we have 15 minutes. We have everything in here. I think is okay. I think I like it. Let's go to the chat, and then on the last final minutes, we'll do arrays. Okay, chat is quiet now. So let's do arrays and circular buffers, starting with arrays. How do I want to use arrays? I already have an answer to that. Just want to have array new and the size of the array. And then how I want to use that, I would just want to set and get But since we wrote these comments, things have changed, because now we can assert things about the setters, or should assert things about the setters as well. And I expect this last one to be L error, because this is out of bounds. The coefficients array has 4 positions. We are doing bounds checking, so when you try to get to position index 4, we start indexing at 0. So in index 4, we'll have an error there, trying to set that value. Same here when I go to that position again. So yeah, now if I try to run this, it's going to fail, saying that the function does not even exist. So let's start defining the functions. Now I'm going to define an array. Let me see. Nicola Lokik, is that how you say that name? Thanks for being here. Hi there, nice content. Thank you. Is there an IntelliSense for JSFX in VS Code? No. Don't you find it hard to code with plain text? Nah, not too much. Okay, so there is a JSFX extension for VS Code. I have never actually installed it. I think it's good. I haven't bothered. And what that could give me is maybe syntax highlighting, which I could get from the REAPER IDE. It has syntax highlighting. It also has some sort of autocompletion. So there are some goodies in here, but I find that being able to reorder lines and renames, do column selections, and selecting everything with a particular keyword, all of those things are so nice that I end up just using VS Code, and I don't think it's a huge deal that I don't have syntax highlighting, autocompletion, IntelliSense in general. Not for this anyway. If it's like an API that is huge, like Java, where you have to remember 1,000 names, I think that these things are more useful. And even when I'm doing JavaScript or TypeScript, I use that a lot. But using JSFX, I don't care about it too much. Not even syntax highlighting. I have never bothered trying to use the extension for VS Code. So there you go. Okay, so what functions do I have to define? I have to define larray new with a size. I have to define array set with an array, a position, and a value. I'm going to call the position an index. And I need to define larray get with an array and an index. And I know that I will need some auxiliary variables probably, but let's start with this definition first. So what do I want to do? Well, I want to use a struct for this actually. Yeah, I think I'm going to use a struct for this. Now, I could kind of copy and paste the definition of structs, because if you think about it, a struct is a data structure that you index by name. I'm calling the name this fields. And an array is a data structure that you index by number. I'm calling this number an index, but in principle, they are similar. You have to do bounds checking in exactly the same way, pretty much the same stuff. So I could just copy and paste this struct code and change it from field into index and adapt everything accordingly. But I think that instead I'm going to use structs. Yeah, we'll see how that goes. So I'll have something that is private, that is a struct, and that is array definition. And I will call struct define this function over here. What do you think, Nicola? Do you see this and is it like disorienting because there are no callers, or do you use Visual Studio Code for JSFX? So I struct, that is my struct. What are the fields? first the size. And second, the values. And that's another field. So now, what is an array? When I define an array, I'm just creating one of these data structures. And then I'm going to create a local variable for this that I'm going to return at the end, and I need to initialize stuff. So array, well, L struct set an array on the size of the array. I'm going to take this local variable called size, and I'm going to pass it through. And for the values, I'm going to memory allocate size. See how everything is coming together? I think that this is super nice. Now, to set something to the index, I need to check the boundaries. So I'm going to use an auxiliary function for that, because I know that I will need to check the boundary on the getter as well. So call this L underscore underscore because it's private, and is, how do I call the other one? Is valid field. Is valid index. Why not? Given an array and an index. And in this one, what I have to do is L struct get from the array its size. And I will check if the index is less than the size. Then, to set something, I'm going to check if it's not the case that the index in the array is valid, then return an error. Otherwise, go to that position. So L struct, essentially something similar to this, but instead of getting the size, I will go to the values. And that is an array. That is a chunk of memory that we allocated here. It's a chunk of memory. So because it's a chunk of memory, we can just go to index and set the value. And something similar in the getter. Oh, it's so nice. When you have all the pieces, they just lock together, and it's like great. I'm so happy with these lines. I will be even happier if they work. So Nicola is saying, thanks for the answer. I don't know JSFX myself, but would like to learn. These videos will be a great resource. Hopefully they will be. I like VS Code more than Reaper's IDE, but would find it easier with syntax highlighting and IntelliSense. Yeah, that's a good point. It's a fair point. So maybe you can install the extension. What is it called? Reaper scripting extensions. But I think it supports JSFX, right? Oh, it may be just for Lua code for Reaper scripts, not for Reaper audio effects. Yeah, but I have already on my list of things to do. It could be nice to have an extension for JSFX for VS Code. So maybe I will do something like that in the future. Who knows? So it doesn't exist. It seems like it doesn't exist. Fun stuff. Okay, let's go over this again. So array definition is a structure that I define, and then I have two fields in this structure, the size and the values. To create a new array, I get its size, and I'm going to create a new one of these structures. And I'm going to set. Oh, I don't think it's L underscore underscore set. I think it's like this. And the same here. Yes, because these are not private. These are private. So create a new data structure, which is an array, set the array at the size to the number size, and set the values to just a memory chunk that I allocated with that particular size, return the array. Do I have a valid index? That will be necessary for setting and getting because we are doing bounds checking, memory safety. So I take the array and the index, and if the index is less than the size, then it's a valid index. To set a value to the array, I get the array, the index, and the value, and I check if the index is valid, return an error if it's not. If it is valid, I will get the values, which is chunk of memory. I index into that chunk of memory and I set the value there. To get, I do exactly the same thing. All right. So I think that all the names here are correct. I am confident in testing this. Let's check it out. Okay, a bunch of tests are failing. Even tests that have nothing to do with arrays, it seems. Let's commit what we have and try to figure out what could be going wrong. It's funny because I'm only adding... it seems like a memory safety issue because I'm only adding... Oh no, I think I already know what the issue is. I'm only adding new code and yet old code is failing. And that's weird, right? And it is a memory safety issue. Let's commit what we have and then we'll go over what the issue is. The issue is that I'm trying to define a struct, but in this context, I am not in a place where I can define structs because structs use memory and this hasn't happened yet. I could just not have that, right? But if I just don't call this, if I don't call this, everything in the memory begin situation will not occur. So these values will be undefined. But that's all right. What if I just set them to 0? And then at the end, I guess if I don't have a begin, I might not have an end as well. I was going to try to run JSFX here on the console. I think that just by doing this... So let me go over what the issue was. I was resetting memory after having defined a struct. But a struct uses memory. So I was like initializing memory after having defined the struct. So this would be effectively junk. Memory safety issue. Now, if I don't call begin... If I do it like this, then I am explicitly initializing the thing to 0. I'm hard coding the initialization. Then I am not going to have junk in memory. And I think that all the tests are going to pass now. And they all pass. So let's revisit this. Do we want to have... So there are two solutions for this. I can just not use structs to define arrays, or I can not have this part. I think, and this part is good because it gives you flexibility. It helps you use my library with someone else's library. But just maybe, I think I will need a bunch of data structures all over here because I want to have things like filters. I will need data structures for that. So maybe I don't want to give you this flexibility. It's not awesome, but I think it is what it is. If I don't have a begin, I don't think I need to have an end either. Because what is end doing? It's doing free and buff, which is just a suggestion. And if you're using someone else's library, it's not even going to fly. So, yeah. And if you want to use another library, you can peek into this variable. And you can use another library as long as the other library is going to let you define the base address for memory allocation. And the only other library that I know for JSFX lets you do that. So that's fine. You can just use my library first. It's not ideal. Don't really love this. And then this address start situation isn't used anymore. And then we end up with this, which is super short, and I kind of like it. In terms of memory allocation, you just have the next available address. It starts at 0. Then you just increase the size, you set the memory to undefined, and you return the address, and everything works. Yeah, all the tests are passing. Great. Yeah, not awesome, but good enough. And from the user's perspective, there is less ceremony. You can just start allocating stuff and defining enumerations and whatnot. So you don't have to be explicit about ending the memory segment either. And as long as you follow the tenet that you can only allocate memory in the init block, you can think of the init block as the place where you allocate memory. You don't have to be explicit about beginning and ending the memory allocation block. I'm not in love with this, but I am okay with it. So we did a race. Yay! All right, let's see. Awesome, heart. I heart you back. Let's try to do circular buffers, or maybe just a circular counter. Yeah, let's do a circular counter. It will use a box. It will be a lot of fun. So let's see. Right after array, I will have a circular counter. Let's see how I want to use the circular counter. Right after array, I will have something that is a circular counter. I don't know of an example of this that is not in a circular buffer. So maybe I don't want to expose this to you. But it's like an oscillator. It could be useful. Yeah, I think it's useful if you are defining an oscillator. You probably want to have a counter like this. Yeah, I'll have a circular counter as a primitive data structure that you, the user of the library, can use. So I'll just call L circular counter. Is there a better name for this? Like a canonical name for this? Circular counter. Yeah, I think it is a circular counter. I have ring counter. Yeah, I think that's more or less what I'm building. Yeah, I think that's more or less what I'm building, so I'm gonna go with that name. And I think to define a circular counter, I need this start. So let's say that it goes from 10 to the end. Let's say that it goes to 15. And it needs to have an initial value. Let's say that it starts at 13. And it needs a step. So let's say that it goes up. It could be going down. It goes up. Yeah, is this how we define variables here? We define initial value, then start, end, and step. Yeah, I think I'll do it like this. Okay, so initial value is start, end, and step. Okay, looks good. So I cannot increment the circular counter on the tests because of the issues I mentioned before. It's running in a loop. So instead, I'm going to, I guess, just Yuck. I could just increment the counter a little bit here. Or maybe I can have something to reset the counter. I think I will need that. So yeah, I'm gonna have that. Yeah. Okay, so let's go to the tests and write some of them. So I will assert that I will do some circular counter reset first. That's super important. And that should be equal to 13, which is our initial value. Then I will assert that L circular counter increment that should give me 14, right? And then when I increment again, it should go to 15, or do you want to not make that inclusive? Most ranges in JSFX are not inclusive, so I'll make that not inclusive. So it goes from 13 to 14, then instead of 15, it goes back to 10. And then when I increment again, it goes to 11, just for good measure. So I will need a reset, and it's not increment, it's a step or update. I'll call it step because it may be going down, and in that case, it's a decrement. Looking at the thing and see if I like it. Yeah. Circular counter. New. Initial value. Start and end and step. Reset the circular counter. Step, step, step. Wrapping around. Okay. Let's define this, guys. We'll need 3 functions. That function, and this and that. And these 2 guys are functions. And all of these 3 guys can take a space and a new line. And then for when I'm creating a new circular counter, I'll have my initial value. Call this like just the value. Start, end, and step. And when I reset and when I step, I just have a circular counter as argument. Right, so what is a circular counter? Well, it is a data structure. So L underscore underscore, because it's private, struct circular counter is equal to L underscore struct new, not new, define. And a circular counter definition, I suppose, right? Yeah, circular counter definition. I don't think there is a single time that I had to write definition that I got it right the first time. Then I will have fields. The first field will be the initial value, and I guess I'll call it the initial value. And then I'll have start and end and step. Start and step. But very importantly, I'll have the current value, right? That's essential. So what is a circular counter? It is just L struct new of this. And then I'll have a local variable. You see where this is going, right? Everything is super similar. This is similar to what I did in arrays, for instance. I'm going to return the circular counter at the end, and I'm going to set a bunch of things. So L struct set of this into the field initial value. We'll take the initial value. And then the same for start and end and step. And for current value. So start, end, and step and current value go into these positions. And then here I will have start and end and step. Looking good. Then to reset, I just set the value to the initial value. What is the initial value? Well, I just get this. And that. And I change this to a get. And I suppose that this line is so long that I better do this. To reset the circular counter, I get the circular counter and I go to the current value and I get its initial value and I set it back. All right. And to step, now that is going to be more interesting. I'll have a local variable called current value. And I will say that the current value is equal to getting not the initial value, but the current value. Why am I calling these guys values? Should be like counter. No, I'll let that stay. And at the end, I will want to have the current value. I want to return that, right? Yeah. So actually what I want is to be able to set this. Yeah, I want it to be like this, because then I am sure that I have stored the right thing. So I will not have a local variable. Or do I need a local variable? Let me think. Maybe I will need a local variable. We'll see. Yeah. Okay, maybe I think I will need a local variable. Let's see. Let's set this guy. So current value plus equals this, which is I need to get the step. And then I need to wrap this around, right? So I think I will also need the notion of a range. You'll see why in a moment. Not range. Range is equal to the and minus the start. And I think I already have some tests that I need to write. To do test circular buffers that aren't integers and that step down. Negative steps. Yeah, I think I'll remember that tomorrow. So this is the range, and now I'll have two while loops. And while loops are something that we haven't actually used yet, but we're going to use it now. So the current value, well, I guess I'm going to also extract the start and end, and yeah, I think I'm going to extract the start and end. So I'm already extracting the current value. Why not extract? I'm thinking about the order of these things. I think I prefer to have it like this. Current value is probably the most important thing in this, so it goes first. Yeah. Yeah, current value, and then start, end, and step I will only need once. Okay, I'm getting my head around the thing. I will need to extract the current value, the start, the end, and the step I will only use once, so I will not extract it like this. Then I'm getting the current value, and I also need to get the start and the end. And then, so I extracted everything that I need, and I can compute the range more easily because I already extracted the start and the end. And then the current value plus the step. Then while the current value is greater than the end, I will current value minus equals the range. And while the current value is less than the start, I will plus equals the range to bring it up. What this is doing is, if you go over the range, you subtract the range, so you wrap around. And this is better than using, these two while loops are better than using. Sometimes you will find uses of the modulo operator for doing this. It's better because this works with fractional numbers, floating point numbers. And also, if you need to wrap multiple times around, so if your step is bigger than your range, this will also work. Otherwise, I could have used an if, because you would only go over, if your step is smaller than the range, you would only go over once. But if your step is bigger than your range, then you could go over multiple times. So that's why I have a while here. So while the current value is greater than the end, subtract, and while, in one of these I need an equals in this one. Because if the current value is equal to the end, I already need to wrap up because the end is not inclusive. But the beginning is inclusive, so this is fine. And all of this arithmetic I'm doing thinking that the end is bigger than the start and that the step is positive, but I think that it all plays out if I do it in reverse as well. I think that the mathematics just pans out correctly, but I still need to test that. Okay, let's review what we have and try to test it and then wrap this up. We have 10 more minutes. I was going to go until 8, but I'm going to go until 8 and 8:30. Okay, so the counter definition is a struct that has these fields: current value, start, end, and step. To create a new circular counter, I give it the initial value, the start, end, and step. Then, here, I instantiate a new one of these data structures. I set the current value, initial value, start, end, and step, and return that. To reset, I just set the circular counter back to its initial value. And to step, I just get the circular counter, and I go I extract the current value, the start and the end. I also get the range. Then I increment with the step, and then maybe I don't need these spaces. Then I clamp the value to be in the range. Oh, and I need to set it for later. Current value is current value. Oh, but check this out. A setter already returns the value. So I don't need to have a deadline. I can just have it like this. All right. Let's give this a try. Okay. Syntax error. I may be missing some parentheses. Now it's wrapping, so there is a problem with my test library, right? I think I'm gonna have something like underscore assert counter starts at 0. Or maybe, yeah, whatever. Assert counter starts at 0, and on every assert, I am going to increment 1, and that's not how you do this. I will check if the counter is divided, let's say 10 assertions, then print a new line. Can you do that? Is that gonna work? Okay, it's not. It's not going to work. Oh, that's just annoying. Now I'm conflating two things that have nothing to do with one another. Fixing the assertion and doing the circular counter. Let's commit the circular counter. I think that the circular counter is passing. Yes, it is passing, isn't it? How about I just comment out, this is ridiculous. I'm going to comment out all the other assertions, or at least some of them, so that we can see the assertions that we are interested in. There you go. Circular counters are doing their thing. They are passing. So for the next time, we are going to fix the assertion library, the assertion facility itself. Okay, that was a good run. Today, we implemented arrays, circular counters. We reviewed everything. We improved things about memory allocation. This is working out fine. I'm happy with this. To wrap this up, I am going to commit what I have on the other repository so that you can see this on GitHub if you wish. There you go. It's on GitHub now, and I'm going to sign off. Let me just make sure that no one said anything else on the chat. And I see you all tomorrow over here. We are going to continue this. We'll probably finally implement the circular buffer. But you can imagine that this is going to be super quick. So we'll probably move on to some other things down the list. Maybe I'll skip to something like filters because it can be fun. We'll see. I don't know. You have to tune in tomorrow. You have to subscribe. You have to ring the bell. You know what to do. I see you tomorrow. Have a good one. Bye.